Hey party people! In this video we're going to answer the question, how do we find the area of oblique triangles? We're going to break this into two cases, whether or not we know side 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 or side angle side. If we know side side side, we can use Heron's formula. It states that the area is equal to the square root of s times s minus a times s minus b times s minus c, where a, b, and c are the three sides of the triangle. And this s can be found by adding those three sides and dividing by 2. Now if we know side angle side, we can use that the area is equal to 1/2 of BC sine A or 1/2 AB sine C. All this is the two sides that you're given multiplied by the sine of the included angle. And to actually see where this comes from, we know that the area of a triangle is 1/2 base times height. So I'm going to make B my base here, and this is H. So if I think about this angle right here, this is angle A because it's across from side A. Well, from this, since I formed a right triangle right here, I could say that the sine of A is equal to the height over C, or that H was equal to C sine A. Substituting that back into this problem, we get that the area would be 1/2 of B C sine A. And so that's where these formulas are coming from. Alright, so let's put these to use. Here I have a triangle with these three sides that are given, so now I'm going to use Heron's formula, and we're going to find the area. Well, to use his formula, first I need to figure out what S is. And to do that, I'm just going to add up all three sides and then divide all that by 2. If you're using a calculator, I suggest putting this in parentheses. So from this, we get that S is equal to 84 centimeters. Now I'm ready to plug into Heron's formula. Alright, so here I have his formula, and so I'd say area is equal to the square root of 84 times 84 minus 43, and just go through and plug in these numbers. So once we have all this in here, we can just evaluate, and we see that the area of this triangle is 1,131.9 centimeters squared. Right, here I have a triangle that I want to find the area, and I have the two sides with an included angle. So this is a pretty easy case here. We're just going to use the other formula, 1/2 of AB sine C. So area is 1/2 of those two sides, 5290 sine 102. Make sure our calculator is in degrees, and the area is equal to 2,288.9 meters squared. But remember that this can only be used if we have side angle side. Right, but what if we don't have side angle side? Well, then I have to look, okay, I have side side angle, so I can use law of sines to figure out another angle inside of this triangle. And because I have angle A and side B, I'll find angle B. Remember that because it's side side angle, this is an ambiguous case, so at one point we're going to have to be careful. Alright, so I've set up the law of sines here. Now I'm going to multiply this side by 500, and I get that the sine of B is equal to 0.446. And because this number is not greater than 1 or less than -1, we can find a solution. So now I'll take the inverse sine of 0.446 to get that angle B is equal to 26.5 degrees. Alright, so now I can go back to my triangle and plug this in, 26.5. And now I can actually find angle C by just taking 180 and subtracting these two angles. That gives us that angle C is equal to 113.5 degrees. Now at this point I have side, angle, side, so I can find the area just using my formula from before, 1/2 of 720 times 500 sine of 113.5. And the area of this triangle is 165,070 units squared, because we didn't specify a unit. Alright, and that's finding the area of oblique triangles. Goodbye.